Okay, your reaction is sodium iodide plus copper nitrate. And I assume you got a precipitate. So you can figure out what the precipitate is. What you do is an exchange of the ions. So you see sodium is +1, iodine is -1, copper is +2, and nitrate, if you look that up on your polyatomic table, that's -1. So that's why the formula is the way it is. And the AQ means that the water is already in the equation, so you don't have to have actual compound water in the equation. So anyway, so when they do an exchange, that means the cation from the first material goes with the anion of the second. So you put those two together, look at the ion charge, you see it's a 1-to-1, +1 and -1, so you don't have to have multiple nitrates on the sodium. Then the copper, it was a +2, and so it's still a +2, and so you have, since iodine is -1, you have to have two of them. And that, I'm assuming, is the solid, because if you look at your solubility rules, all nitrates are soluble, meaning they dissolve in water. So if you saw a precipitate, it would be the copper iodide. Okay, so now you have to balance that equation, and I didn't do that. So that's what I've written here. I've said copper must have a +2 charge since it is attached to the two nitrates. Therefore, copper iodide is the formula, now balance. Now, when you write the net ionic equation, you write everything in terms of the ions. You break those compounds up. And so you would have the complete ionic equation, and then what you're doing is separating out the spectator ions, the ions that are the same on both sides of the equation, which would be eliminated. And once you do that, you'll find that the only thing that's involved in the actual making of the solid material are the ions that are involved in the actual solid material. So it would be the iodide ions and the copper ions, because everything else, the sodium and the nitrate, are still in solution. They're spectator ions. What's involved, the net ionic, means only the ions that are involved in making the solid, or if it was a liquid, but not other ions. And so your net ionic equation would be like this, but you have to balance it again.